In this video, we're going to consider finite state machines. A finite state machine consists of states, inputs, and sometimes outputs. The number of states is fixed when an input is executed. The state is changed from one state to another, and an output is possibly produced. In this example on wikibooks.org, we're going to consider this state transition diagram. We have a starting state and we have an accepting state with two rings around it. We have state 1 and state 2. State 1 is the accepting state. This state finite state machine accepts binary numbers, ones and zeros. A 1 will be accepted and will remain in the same state. A 0 will change from one state to another. 1 will keep us in the same state. The finite state machine, for it to run successfully, has to end in the accepting state. And in this case we'll see that this finite state machine needs to accept an even number of zeros. We'll now consider a state transition diagram of this. We have state 0 and state 1. We have an input of 1, and that brings us back to state 0. So the current state is 0 and the next state is 0. Another input of 1, and we have state 0 to state 0. An input of 0 takes us from the current state 0 to the next state of 1. So now we move over here. Another input of 0 takes us from state 1 back to state 0. So the current state is state 1 and the next state is state 0. An input of 1 again, and we simply move from state 0 to state 0. Another input of 1, we remain in the same state, 0 to 0. An input of 0, and we move to the next state from state 0 to state 1. And another input of 0, and we move back again from state 0 to state 1, and then a final input of 1, and we remain in the same state, and the last state is the accepting state, and therefore this has worked. We will now step through this example with 1 1 0 0 1 1 0 1 1. Here we go, we have an even number of zeros. 1 1 0 0 1 1 0 0 1. And we'll run this simulation. So we start with 1. 1, we're still in state 0. 0 takes us to state 1. 0 takes us back. We run it again. 1 0 changes states, 0 changes states back, and the final 1 keeps us in state, and it's accepted because we've terminated in the accepting state. Let's look at an example where the input has 1 2 3 zeros, an odd number of zeros. We start in state 1 and we remain in state 1. There is 0, and then the 0 changes states from 0 to 1. The 1 remains in the state 1, 1 to 1. 0 changes states again, so we move from state 1 to state 0. With the 1 we remain in this state. 0 changes state again from state 0 to state 1, and the 1 remains in that state, and the last one remains in that state. And unfortunately, because we haven't had a 0, we terminated in state 1, which is not the accepting state, and therefore this is not accepted. We'll now run the simulation with 3 zeros. Change states, change back, change states, and terminate, and it's rejected because we're in state 0. Thank you.